Good afternoon, everyone. Today, I myself, AK, and Room for Agmo. I believe some of you guys have attended some blockchain sharing, but ours one will be quite different because a lot of blockchain companies, they actually start with a proof of concept where we actually have quite some products in the production environments. So today, we'll walk you through a few agenda about ourselves and some of our blockchain products in the production in the POC stage, then some of the fundamental blockchains, then also about blockchain technologies, because you must be hearing a lot of blockchain technologies. Then you might be wondering what's the difference between all these technologies like Bitcoin, Ethereum, EOS, Tron, Hyperledgers, and many, many more. Then after this, we also have a case study lab. So it gives you 4 case study. Then based on what you have learned on the this agenda, then you will be able to differentiate whether which blockchain technology should you use based on the criteria. Then lastly, we will have a detailed case study. We also what to you we have implemented using one of the blockchains that we will actually share with you what is the alternative way of implementations. Lastly, we have a Q&A. So these sessions will be roughly 1 hour to 1.5 hours. About myself, so my name is AK. I'm founder and CEO of Agmo Studio Sdn Bhd. So since incorporation, we have helped we have mainly served corporate segments. We serve 10 Fortune 500 companies, some of the top listed companies in the regions, including 1/3 of the KLCI companies to digital transform using mobile and blockchain technologies. So I myself is also a president of Malaysia Mobile App Developer Associations. Then I'm also a trainer for Apple Southeast Asia iOS Trainer education programs. Then I'm technical advisor for 2 of the cryptocurrency startup, MS Exchange and Bitcoin app. So I'm also a technical mentor for Magic. And I am featured as one of the 16 notable Malaysian software ninjas. I've been doing software programming in the last 13 years. So I'm also a lot of hackathon judges. Then next is Rong. Rong is our blockchain developer. So he is an experienced full stack developer that he can do blockchains, web Angulars, backend with C# and cloud on Microsoft Azure. So in the organization, he has been helping to develop quite some of the blockchain products, including Work to You, election blockchains, and also a product tracking blockchains. And next one, so we'll share a bit on what we have done in the productions. So the first one is Work to You. Work to You is a remote participation and voting platform. Basically, we help public listed companies to host their AGM online. So far,
okay, boleh tanya?
Yeah.
Kalau nak belajar dengan you, berapa hari boleh pandai?
No, I think belajar is not really important. The important you need to be interested. You need to be passionate. More practice. Software is always about get your hand dirty, do more assignment, do more on hands-on. I think you will be very pandai already. So you don't really have to learn from me. You can learn from internet also. Right. But then of course, what we previously we conducted some blockchain training for UM, UTM. So what we do is basically we help them to reduce the unemployment rate. As you know now, the fresh grad, maybe they are lacking of some new skill. So we upskill them, help them to learn blockchain faster. It's like a shortcut so that they can learn blockchain faster rather than they bump into the wall themselves. Yeah, later we'll share a bit more as well. So let's go back to the Work to You. So this is blockchain platforms that help public listed companies to host their AGM online. So far, we have helped more than 50 public listed companies to host their AGM, including Post Malaysia, Alliance Bank, MyEG, and so on. So why we use blockchain is, of course, voting for public listed company is very important because it could actually change the substantial monetary value decisions, or you can appoint a good or bad directors. So that's why the public listed company doesn't want the developers to have the ability to tamper the result. So we are using blockchains. Secondly is the election blockchain for the MMU. This is a student representative council elections in 2019. And we are the first and only one doing this in a large scale. We have about 6,000 students work in the 3 campuses concurrently in Melaka, Cyberjaya, and Johor.
Okay, in curiosity,
yeah.
How much do you charge?
Which one? For this one or this one?
For MMU?
MMU, because I'm the MMU alumni. So it's actually really cheap here. I think about 5,000 for 3 campuses.
All right.
Yeah, alumni price. Yeah. So we also filed patents with my IPO with our novelty. So our novelty here is that because using blockchains by right, all the transaction is black and white, everyone can see. Then our special part is basically we anonymous the voter identity, so that using blockchains, we can use the audit trail with full transparency, yet you don't know who worked for what. So this is basically our novelty that we found the patterns. Then apart from that, we also have the electronic health record on blockchains. If you open My Sejahtera under digital healthcare, virtual health advisory, you can see our product called Talk to Us. So in Talk to Us, we provide COVID-19 health advisory to the rakyat and this is a free consultation. So in the Talk to Us, we also have a biodata. So basically, biodata, we store that in the Hyperledger blockchain. And this is also, we represent Malaysia to win in the Asia Smart Air Awards this year. So next one is Blockchain. Blockchain is an extension of the electronic health records. As you can see, Talk to Us is actually one of the users that focus on the medical records only. What we are doing here is basically we expand it from medical records. We want to do financials and education record as well, so that it become a one-stop personal record management center and is stored in the blockchains. Then from here, imagine, let's say I go to the banks, I want to show my credit record to the banks to apply for a mortgage, and just show my QR code, then the bank can scan, then I can request for my consent. After my consent, then the bank can get my credit records from the blockchains. Of course, we don't integrate with the banks yet. So the only user that we have is Talk to Us, to be honest, at the moment. But we believe this one has a huge potential. Then we also represent Malaysia to compete in Armenia back to 2019. Nominated by MTech and Picon. So next one is GetCoin app. GetCoin app was our product to help laymen to buy Bitcoin easily. So it was launched in 2018. Then back then we registered in Bank Negara Malaysia Security Commissions. Until Security Commissions launched a new digital asset exchange license, we didn't get it, so we ceased our operations. But we were one of the pioneers to do this in Malaysia. Then recently, we win in one of the government hackathon by Mosty and Credder. So it's called My Marathon. So under these competitions, we will get the opportunity to implement the pin book. If you know a pin book that the pregnant woman used to store the antenatal and vaccination records. So we are going to digitalize that pin book using blockchain technologies.
Hello.
Yeah, hi.
Can I ask something?
Yes.
How do you implement the blockchain technology in the ping book application? Can you tell more?
Okay, so what we are doing here is basically okay, I have another slide for that, but I can tell you on a high level perspective. So basically in the vaccination records is something very important. You can't allow anyone can just go in to amend the data. So that in our system, we have 3 rows. The first row is the parents themselves. So the parents can read the vaccination and antenatal data. Then the second row is healthcare professionals. Basically, they are doctors in the clinic Kesihatan and government hospital, so that they can scan the QR code basically to update the vaccinations and health records of the mothers and the kids. Then the third row is also a read-only row, mainly used for school, so that before the children admitted into the school, then the school can scan the QR code to verify these children has been taken all the necessary vaccinations. So the importance of the blockchain in this ecosystem is basically you want to ensure all data is stored correctly, no one has tampered it. So let's say this kid doesn't do any vaccination before, but just that maybe his friend is working in the maybe in the IT company, so he or she can help to amend the data. We don't want something like that happens, so we use blockchain to securely store the data. Yeah, so this is basically what we are going to do. Of course, we are yet to meet out with MOH. Creator is arranging a meeting with us with MOH on next week. Right. So next one, we also have some blockchain products in the trial run or POC. The first one is a certificate tracker, because under our associations, we actually give certified for the mobile app developers, so that each of the certificate actually have a QR code, so that the potential employer, they can actually scan the certificate QR code to verify this certificate is a real certificate with the name and the associated courses and so on. Second one is a Durian blockchain.
Okay, which blockchain that you use?
For
the network.
Okay, for all products, we all use different network lah. So let's say go back to the first one. So for wood to you, we are using Quorum blockchains, which is a private version of the Ethereum. Then for this one, we are using the Tron blockchains. But since we are using Solidity, we can also deploy to Ethereum, not only Tron. We can also deploy to Quorum because these blockchains, they all support Solidity smart contract. Then for this one, we are using Hyperledger Fabric. It's a private blockchains. And for this one also Hyperledger Fabric. Then for the pin book, we are also using Hyperledger Fabric as well. For MAD, currently we are using Ethereum. Then for Durian blockchains, yes, this is also quite interested. I think 1 or 2 years ago, so MOA asked us to do a POC, but this is a free POC with the deputy minister. Then that time, basically the Malaysia 6 Durians exporters, they get the license to export to China on the whole durian. Whole durian means you see this, the whole one. So in order for this to be able to export to China, China actually requests us to have a very robust tracking system to ensure the durian go through all the proper process. Only they can export to China. So the plan is each of the durian, we give them a QR code so that after the potential buyer in China, they scan a QR code, they know the whole supply chain from start until it reaches in China.
So what are the information that you capture at each checkpoint?
Okay, so each information that you capture will be like in Pusat Kumpulan, who is the one doing this, at where, by when. So these are the 3 elements that we are capturing. By who, at where, by when. Then each of the durian, actually the real one, we also have a sticker there because this QR code you can counterfeit you just print the same one. So after you scan a QR code, you have a sticker, you need to peel off the sticker in order to key in the secret code. So the QR code and the secret code has to be tally in order to recognize this as a real durian. Because cases in China, the Chinese doesn't really recognize this as Busan key.
We need to say that in every checkpoint, somebody have to key in the status of the durian, right?
Yeah. Correct. Yes, at every checkpoint, someone have to key in. Connection, okay. Yeah. Can you hear me?
Yes.
Yeah. So this is one of the case study for MOA, but then it doesn't go to productions. Then next one is for Swire Coca-Cola. So Swire Coca-Cola is basically the sole distributor of Coca-Cola in Hong Kong. So they're basically hosting their annual dinner. Because for annual dinner, everyone says the lucky draw is not transparent. So they want a very transparent way to implement the lucky draw. So we built a prototype called D-Lucky to determine who is the lucky draw winner. Then for Gachapon, if you know these Gachapon machines, for the software version of implementations, a lot of people thought if you play Dota, sometimes you have this random item. Those are based on Gachapon as well. Gachapon is basically a random algorithm. Some of them thought this is actually a predefined software algorithm that in our, so that's why I created Motomor Pets. So this is basically a game app with a Gachapon elements. Then we are using Tron blockchain smart contract to implement the lucky draw mechanisms so that it's transparent. Yeah. Then apart from that, we also have other blockchain initiatives. First one is the blockchain workshop that I mentioned is in University of Malaya, that we teach a student about Solidity programming. And this happened at 10 p.m. until 3 a.m. in the midnight because these are hackathons. But then the students are still very passionate about learning. Then the other one is UTM. So we hosted a couple of 5 days training for UTM students in order to upskill them to decrease the unemployment rate. Yeah. Actually, after the training, we also hire some of the UTM students. Then the next one is a blockchain accelerator. So we partner with MyAG to host the first blockchain accelerator program in Malaysia. So basically, there are blockchain entrepreneurs. They might want to build the idea, but they don't know how. So we, being a technical mentors, help them advise the feasibility and tell them how to build lah. That's about the blockchain accelerator. Then I myself has been doing blockchain since 2016, and I've been a Bitcoin investor since 2015 as well. So we have done a lot of blockchain initiatives in Malaysia. Then yeah, that's about the first part. Any questions before I move on to the second part? Yeah, if not, we can always revisit on the Q&A sessions on certain parts that you want to have more information. So some of the person thought blockchain and Bitcoin is actually equivalent. So obviously no, Bitcoin is actually just a use case of the blockchains. So Bitcoin is a subset of blockchains. Then how we look into evolution of blockchains, just like industrial revolutions, blockchain, we also have evolutions. So Bitcoin started in about 2008 or 2010. So it's like blockchain 1.0. They use Bitcoin as a digital money. Digital money means it has no logic. You want A, I give you 1 Bitcoin, for example, that's all. So second generation of blockchains with a smart contract. Smart contract means we can actually inject source code into the blockchains so that Ethereum blockchain has the capability to execute source code, execute program. Then a lot of people use Ethereum for initial coin offering for the fundraising purpose. And blockchain 1.0 and 2.0, they mainly focus on the public blockchains. In blockchain 3.0, we have the industry blockchains like Hyperledgers, Quorum, Corda. This talking about a lot of like usage in the public sector, like governments, healthcare industries. So the data can be private and permission-based. So Bitcoin is created by Satoshi Nakamoto, but no one knows who is him. But there is one of the historical day called Bitcoin Pizza Day at 22nd of May 2010. Someone spent 10,000 Bitcoins for 2 Papa John's pizza. So it used to worth 475 million like 1 or 2 months ago. But today, due to the Bitcoin price rockets, then currently worth 753 million just for. So the next one, we want to explain blockchain in our terms. Many people try to explain blockchain at many different terms, but from what we see, blockchain is a distributed ledger with consensus algorithm. So the characteristic is distributed in layman terms everywhere, immutable, which is unable to change, history with an audit trail, secure, theoretically unhackable. So blockchain ledgers. Then if you Google ledger, it means a book or other collection of the financial accounts. This is not in our interest lah. So we want to know blockchain definition of ledgers. Essentially, it's a database that is consensually shared and synchronized across network, spread across multiple sites. There are a lot of jargon here, but we go straight to a point where ledger is a database. So in blockchain world, ledger equal to database. Then why we call it ledger instead of database? So the difference between database and ledger is that in database, you have a SQL operation, insert, update, and delete. Whereas in the ledgers, we only have insert operations. There is no update and delete operations. In order to update and delete, basically you call another insert operations. So everything comes with the audit trail. So this is a sample of the SQL database. Imagine I'm the database administrator. So I have the right access. I can simply delete any of the row here without someone knowing. The ledgers, then I can't do that everything with a proper audit trail. Then this is a blockchain ledgers. The first block, we always call it a genesis block lah. Then each of the block, they are linked together with the parent hash number. So like block number 2, it will be linked to block number 1. And then block number 3 will be linked to block number 2. So this is basically the chain of the block. So it's known as blockchain. So each of the block consists of data, my own identity, and the parent's identity, of course with a timestamp as well. How to calculate identity in Bitcoin? We are using SHA-256 hash algorithm. Of course, there are also other less secure hash algorithm. So this is a sample of the hash. Let's say ABCD. This is my plain text. With a hash algorithm, it will become a hash output. The same input always comes with the same output. The chain itself is basically so that the data, after you apply the hash, become your hash. Then the hash will store as linked to the parents one. So this hash number will put into here for the block second second block. Then similarly, second block will hash the data, become my hash, and this hash will be placed here.
How we define the total numbers of nodes required in our blockchain?
Total number of nodes. Okay, I suppose you are referring to the private blockchains. Because for public blockchains, the nodes are everywhere and anyone can become a node. So that is out of our control. In terms of Hyperledgers, the nodes number must be odd number, like 3, 5, 7, 9. So the number of nodes definitely will be depending on the level of sensitivity of the data. Of course, the more nodes will be more secure. At the same time, it also implies a higher operation cost as well and maintenance cost. So that's why there is no fixed number of nodes, but if according to a guidelines, it has to be an odd number, 3, 5, 7, and so on. But how many nodes that you need, it depends on how important is the data they want to secure. Right. So why we use ledger instead of database? Because once data is added, it's impossible to change. Second, once data is added, we cannot delete it. So we actually build a simple, not to say a blockchain, but just to give you a better idea how does a block looks like. So let's say the first one, I want to store a student result. The first one is a CGPA 4.0. Let's show this one first. So student A with the result CGPA 4.0. So as you see, when I am typing, this hash number will change. If I paste back, then I always get back the same hash number. So the hash number will become the previous hash number of the block number 2. Then we have a student B, which is 3.0. Then this hash number will go to here. So this is how we chain each of the block together. Then now we know blockchain is a distributed ledger consensus algorithm. Then we have discussed about ledgers, but what about the rest? The rest are, so ledgers basically give us 3 important characteristics: immutable, comes with an audit trail, and is secure. The next part, we want to go into a keyword, distributed. So what is a distributed network? I mean, we should be all familiar about like the P2B network, such as uTorrent, it downloads movie, videos, and so on. This is a form of distributed network. So in distributed torrent networks, our machines store FLV file, MP4 file. So when someone needs a file, it can download from multiple points. In a distributed ledgers, it's also similar concept. So that instead of storing the FLV file, MOV files, we store the blocks. So that each of the so-called, you can call this a nodes, or machines actually store the full ledgers. So we call it distributed ledgers network. So what is so good being distributed is, you can see the left-hand side is a centralized, second is a distributed. So if I'm a hacker, there is a single point of failure. I just need to hack this one, then I'm done. If being distributed, I have to hack so many nodes together. So that's why the number of security is definitely proportionate to the number of nodes. You have more nodes, then it will be safer. Centralized versus decentralized. In centralized, data are stored in one server, data are not secure. Whereas distributed, data are stored in every node, data are secure. Then in distributed, so it basically brings us distributed and secure. So being a distributed network, it gives us a blockchain characteristic. So if you remember, distributed ledgers, so these two combined actually give us everything already. Then, but why we call blockchain a blockchain instead of distributed ledgers? The difference is distributed itself is basically means many nodes are like uTorrent. Ledger is basically the database itself. Then what makes blockchain special is basically it comes with a consensus. Consensus is a fault tolerant mechanism, blah, blah, blah. This one is very hard to understand. So too long didn't read is basically consensus means how do we make everyone happy. Everyone in this context referring to a nodes in the blockchain network. So without consensus in the distributed ledgers, this is what will happen. So when someone actually file a new block, the green block, then this guy will try to ask other nodes to actually store this new block in their machine. The first one is okay. Second one might not be happy. Third one is totally out of the picture. Last one is okay. So you can see without consensus algorithms, out of the 4 nodes, only 2 nodes has actually added the new block. So that's a problem without consensus algorithm. So how to make everyone happy? There are many consensus algorithms like proof of work, proof of stake, and so on. Proof of work is basically a consensus algorithm. Then when you heard about those mining machines, in proof of work, like Bitcoin and current Ethereum, you need the mining machines in order to create a new block because they are using a proof of work concept. If you are using proof of stake, there is no such thing called mining machines. Proof of work is a very old consensus algorithm. It is not energy efficient. So with this consensus algorithm, like this is basically a miner. Miner found a new block, then each of the nodes in the network will basically add the new block according to a consensus algorithm. So they will basically validate against the block validity before they add into the nodes itself. So in proof of work consensus, only the miner can make everyone happy to add a new block. This miner, they are basically doing complex mathematical calculations, or so something like brute force hacking. But what they are doing is keep on doing the hash calculations. That's why miners machines always comes with very powerful GPU, could be 6 to 8 graphic cards in order to do the mining faster. So proof of work is only one example to make everyone happy. There are many others. Proof of stake, proof of elapsed time, proof of storage. So these are other consensus algorithms could be more energy efficient. Then in terms of mining, just to give some idea. So let's say I created a data, A CGPA 4.0. Then after that, I will mine this. So after mining, basically what I will do is, then I will have a hash number. Then I can continue with the second one. Then I will also do a mining. So the mining is basically to calculate the hash number and so on. So let's say now currently block 1 and 2 is currently correct. Every data is not being tampered. Let's say I try to tamper this data from 4.0. I hate this guy, so I change to 2.0. So the chain will be broken immediately because the hash number doesn't match. So if I reset to 4.0, everything is okay. So when the chain is being broken due to invalid hash number, everyone in the blockchain network will know something is wrong. So the whole definition of blockchain, distributed ledger with consensus algorithm. Distributed, we talk about the many nodes. Ledgers, basically have the block and chain, then they are linked together by a hash number. Consensus is an algorithm to make everyone happy so that we can ensure everyone have the same data. So with all these distributed ledgers and consensus, it actually gives blockchain a very, very, very secure characteristic. Then type of blockchains, we have a public and private blockchains, like this is Ethereum, Bitcoin, Monero. Then we also have a private blockchains like Ripple, Hyperledger, and the BitChain DB. We'll go through more case study. Then in blockchain 2.0, we have an Ethereum smart contract. So this guy created Ethereum. His name is Vitalik Buterin. Ethereum is powered by Ether, basically ETH is like Bitcoin. Then Ether stored in the wallets, and we can create e-apps, so-called decentralized applications on Ethereum network. So this is blockchains. Then they are chained together by the data. In Ethereum, instead of data, we store the code here. So each of the nodes with the Ethereum virtual machine, they can execute the source code. So this is a Ethereum virtual machine. Basically, it's a programmable blockchain. Then you can basically create your own smart contract. Then it can be run as a decentralized blockchain applications. So here, instead of storing the data, it becomes a source code. So the source code can be executed in each of the machines using the Ethereum virtual machine. There are 3 Ethereum testnet, Robston, Hoven, and Winkelby. Because when we develop smart contract, we don't want to use real Ether in order to do a testing. So with this testnet, this is where we can deploy some Ethereum smart contract for development and testing purpose. So we also created some of the sample smart contract. Yeah, so in this smart contract, yeah, the file extension is a SOL, stands for solidity lah. And for those who do programming, you feel this very, very similar and familiar, because this is just like how we define a class. So in this smart contract, we want to vote for the best lecturer. So in here, we have two structures, lecturers, which consists of the name and phone, and second is a lecturer choice. Then from here, it consists of which lecturer, and this lecturer has how many word count. And down here, we will have a smart contract owner address, and this will be the voter address. And down there, this is constructor, just like C++ or Java. Then this is a functions, basically for us to add a lecturer. And the next one is to get the lecturers that you can cast the votes. Then this is add votes, basically for you to vote for a specific lecturer. The only special part is there is something called modifier, new voter only. Modifier means before it execute line 30, it will actually execute a function called new voter only, which will point to this one. So in this new voter only, basically we check against our voter address, then to check whether this particular smart contract user has already called the smart contract before. If there is already called, then of course we don't allow them to proceed further. Then there is also other functions. Then in total, we have only spent about 50 lines of code in order to create a smart contract to vote for the best lecturers. Imagine if you are using traditional programming, that you need to create SQL to store data, everything and so on. So all this is actually encapsulated using a smart contract, which is super simple. You don't care about how the data is being stored. You just need to ensure the logic is written correctly. Yeah, so next one, let's go to the blockchain technologies selections. There are so many blockchain technologies out there. Which one should we use? So I like these flowcharts that I saw somewhere in medium.com. Then if you have a blockchain project or potential blockchain projects, so go through this flowchart. First one, you ask yourself whether you need a database. If you know, then you don't use blockchain. Your blockchain is all about distributed ledgers, data storage. Then secondly is whether it requires share-wide access, means is it multiple persons can write the data. For example, land office, you have a multiple user that could be able to change the land title. Then this one, yes, it will go to the next one. Then are writers known and trusted? So this is also one important element. So if let's say the writers have conflict of interest, let's say it's land transactions, then or monetary transactions, I might have the interest to actually tamper the data in order to create monetary value for myself. But if no, then actually you don't really quite need blockchains. Then after that, it will go to whether you want to use a third-party trustee account. This one, for example, fundraising. Why people use Ethereum for initial coin offering? Because if you don't use that, you will go through some third-party like a trustee in order to hold all the crowdfunding amount before it can release to the so-called issuer. So if you use blockchain, then everything is there. So you don't have to rely on third party. Then the next part is basically determining whether you need control functionality or whether you want a transaction to be private or public. Then that you determine whether you use a public blockchains, hybrid blockchains, or private blockchains. We will discuss further later. So we first go into the public blockchains. Then there are many blockchain technologies out there. So these are those that we have extracted from coinmarketcap.com, which is a blockchain with the highest market capital. Bitcoin is currently the most valuable cryptocurrencies, followed by Ethereum. Then we'll go through each of them. Ripple. So if you use CIMB, then they will tell you they use blockchains for remittance. Yes. So behind the scene, they are actually using Ripple blockchains. Ripple, they focus on financial institutions, basically to help in remittance contests. Secondly, Ripple, they claim themselves is instant and also low cost. Next one is Chainlink. Chainlink is very interesting because they provide infrastructures for smart contract to connect to the real world data, events, and payments. This is how it works because smart contract we actually stay within our ecosystem only. But in the real world, you will have the other data, for example, API or cloud or analytic data. You need to feed into the smart contract, and this is input perspective. Similarly, from here, you also need to output. Maybe after the smart contract calculation, you need to remit some payment and so on. So you can also send payment to the banks via this chain link. So this is a chain link infrastructures, which is quite interesting. It allows you to interface with the conventional cloud API apart from using the blockchain infrastructures. Then the next one is EOS. This EOS is, you can see it's a more scalable version of Ethereum. Stellar. Stellar is an open network for storing and moving money. It is very similar like Ripple, but Ripple focus more on financial institutions, there are banks and so on, where Stellar focus more on consumer market. That people, some of them use it to create e-wallet. For example, you can imagine Touch and Go boost, they can consider using Stellar to do their e-wallet. Tron is also similar like Ethereum, but just that it comes with more high throughput. Basically, the transaction per second is higher, high scalability, and also high availability. So this is a Tron performance. They benchmark themselves against Ethereum and the Bitcoin. Bitcoin is only 3 to 6 TPS, Ethereum 25. Tron can go up to 2000. Next part is private blockchains. Private blockchains, the first one is the Quorum that we use for work2you. So Quorum is created by JP Morgan, the huge investment banks. Then after that, acquired by Consensus on the Quorum technologies. This is a private version of Ethereum blockchains. Secondly is Corda platforms, which is also a private blockchain as well. Then the third one is Hyperledger, which is very, very mainstream in the private blockchain industry. There are many variants of Hyperledger as well, like Calibre, Celor, Explorer, Fabric. There are many different kind of natures. Depends on the use cases. Some of the variant might be more suitable for you. Then next part, we touch a bit on the regulations. So just like I share a bit on the digital asset exchanges, which is now regulated by security commissions. Digital asset exchange means if I want to buy Bitcoin with Malaysian ringgit or vice versa, then I need to go to digital asset exchange. There are only 3 approved digital asset exchange in Malaysia at the moment, which are Luno, Synergy, and Tokenize. Next part is ICO. So ICO stands for Initial Coin Offering. Now it's being regulated by SEC. So let's say I want to create a new blockchain applications. I want to do fundraising. Then I myself is an issuer. With the issuer, then I need to apply with someone. Like IEO stands for Initial Exchange Offering. You can see IEO is like IPO lah. That you buy IPO from Bursa Malaysia. You buy ICO from IEO. So that's the difference here lah. Then the next one I want to share a bit on some of the incidents happen in the cryptocurrency world. Because some say Bitcoin is not secure and so on. But pretty much Bitcoin is quite secure until we created quantum computing. Otherwise, it is very secure. But some say Bitcoin is being hacked. What happened behind the scene is actually some human mistake. So I will go through some case study. So first one, the Ethereum price crashed from 319 become 10 cents in one of the largest exchange in the world. So what happened here is because they didn't implement what we call a VCM, volatility control mechanism. Like Malaysia Bursa market, we have something like limit up, limit out, right? But in crypto market, there is no such thing. You can drop from 319 to 10 cents. So that doesn't make sense. Secondly is some of the name is also one of the cryptocurrency is being stolen. 534 million of the name tokens are being stolen. So the main reason is they are using a hot wallet to store the token, whereas the recommendation is using a multi-sig cold wallet. Hot wallet means the private key is connected to the internet. If it is connected to internet, it's vulnerable to hackers. If using cold wallet, the cold wallet is stored in the token, something like a pen drive. Then after that, when you need to do transaction, you plug in the pen drive. Only the computer will read the private key from the pen drive. It is not really a pen drive. They call it a cold wallet. Then the next one is basically a founder of the exchange debt, and then all the cryptocurrency is gone. They are using cold wallet, but then the problem here is that there is only single user. When this guy is gone, then all the money is gone. Because unlike banks, someone that you can go and basically reset the bank account with the proper documentations, while in cryptocurrency world, no such thing. Private key is gone, means the money is gone. Then the next one is also about the Bitcoin. Then in this, what happened is the hacker take advantage of a security protocol due to a single point of failure. Although they are using BitGo, which is a secure vault storage, but they are not using a real multi-sig security framework. Multi-sig stands for multi-signature. Means, let's say, to endorse the transactions, I need 3 or 5 authorized signature owner in order to approve the transactions. This is what we call multi-sig. Yeah, so next one, let's go to the lab sessions. Then we have 30 seconds for each case study. Case study 1, company A would like to launch a crowdfunding event to develop their blockchain projects. So we will let you to choose which blockchain technology would you recommend them to use and why. Okay, so first one is, so keyword is crowdfunding. Which blockchain should you use? Okay, so there is no right or wrong answer, but there is a, to me, I will feel which is the best answer. To me, is Ethereum at this moment of time. You can use all of this technology for crowdfunding, but why Ethereum? Because when we do crowdfunding, we are looking at liquidity. Means after you buy the token, whether you can sell it easily or not. That is how we push out the value of the token. And if you look into the world, most of the ICO is done using ERC20. So this ERC20 is a protocol for Ethereum. Once your token complies to this ERC20, which is by Ethereum, then your token can be easily adopted by other exchanges. So that's why Ethereum is being very mainstream in the ICO industry. So this is your first one. Then let's go to the second case study. Second case study is the client is a Ministry of Health of a country. Then they would like to launch electronic health records for the citizens, which will be consumed by the citizens' clinic, pharmacy, hospital, lab, and insurance company. So which blockchain technology would you recommend to them to use and why? So, yeah. So for this one, the answer could be pretty obvious due to the health record is quite private. So I will always use a private blockchains. So the first 3, they are all public blockchains. So I will skip that. Then definitely I will use Hyperledger for this. But if you encrypt it properly, even though we are using a public blockchain, we wouldn't know what is inside the data. But to play safe, since health record is so sensitive, we don't even want a chance of this data being compromised. In today, it might not be compromised due to the computer. It's not that advanced yet.
Yeah. Okay.
Yeah.
Okay, then go.
But Ethereum also we can build up within the private network, isn't it?
Sorry?
Ethereum also we can build in within the private network.
Yeah, right. Yes, you're right. But then the private Ethereum, okay, then that comes to 2 things. First thing is the private Ethereum, yes, Quorum is one of the example, or you can self-host Ethereum, that's also correct. But then Ethereum doesn't have a very good, what we call the ACL mechanisms, access control layer. So you can't really control, like let's say, doctors can only write this record and pharmacies can only write poison records, for example. So Hyperledger comes with a better control.
Ethereum already have their enterprise version, right? To cater all the requirements.
Yes, enterprise version, yes. So I'm referring to another part which is on the Rapid ACL. So this ACL is an access control list features where Ethereum doesn't have it at the moment. So this access control list can give us flexibility like, let's say I'm a doctor, I can update the biodata. Let's say I'm a pharmacist, I can also only update the drug records. Let's say I'm a lab, then I can only update the lab test record. For Ethereum, this mechanism is not built into place. That's why there's this advantage of Hyperledger Fabric. Yeah, so again, Ethereum is not wrong also, but just that in order for you to implement the ACL, then you need a lot of efforts because that access control is not built into Ethereum.
We want to start this blockchain. So is it advisable for us to start with Hyperledger compared to Ethereum because it already covers everything?
Depends on the use case. Yes.
Your recommendation?
Depends on what you want to build. If you want to build health records, then at the moment, I think Hyperledger is a suitable one. Right? Okay. So this is, yeah.
A very disturbing dia punya echo tu.
Okay.
Mr. I, can you repeat again? Because just now kan ada interruptions tu. I couldn't get cannot get what you start trying to explain just now.
Okay. So we were discussing why do we use Hyperledger instead of Ethereum. There are many reasons out there. So first one is basically about the ACL, access control list. So in Ethereum, basically, if you are the right user, then you can read and write everything. For Hyperledger Fabric, it comes with an access control list. So let's say I'm the doctors, I can read and write the health data. If I'm a pharmacist, I can read and write the drug data. If I'm a lab, then I can read and write the lab data. So things like that is already built into the Hyperledgers. If let's say I'm a school, I can only read data, I cannot write data.
Talking about the technical implementation, is it different between Ethereum and Hyperledger?
Yes.
If let's say we start with a small systems.
Yes, it is very different. So in terms of the programming language in Ethereum is using Solidity. Hyperledger Fabric is using Golang or also the Node.js. It's very different. Then in the infrastructure is also very different. In Ethereum, you have remix, which is very easy for you to do writing smart contract. Everything you can do on the browser. But in Hyperledger Fabric is quite difficult. You need Docker and so on. I wouldn't say is friendly for developers. Ethereum is very friendly. Then the third reason is because the infrastructure also. For Ethereum, you can simply deploy to a testnet. You don't have to care about the nodes provisioning and so on. In Hyperledger, you have to take care of the nodes setup, connectivity, certificates, everything. But Hyperledger, it comes with a higher scalability. Due to Ethereum is using proof of work, so the block time is very slow compared to Hyperledger, which is much faster, and it can support more transactions per second.
Okay, let's say we start with Ethereum for our first project, and then we are having an upgrading version for our system, let's say. So can we move to the Hyperledger easily, or we need to change the whole infrastructure that we have inside the Ethereum?
Okay, so the answer is it depends. So for example, if you are using Solidity, then Solidity is supported in Ethereum, Quorum, and Tron. So yeah, if you are porting from Ethereum to Tron, then you don't have to rewrite everything. Some of the things is already there because they are all supporting Solidity. Then if you are moving from Solidity to Hyperledger, yes, a lot of things. I think basically you have to redo everything. So that's why for Security Commission actually they launched something called they launched something based on ERC as well. Can't find a case study. Okay, but basically this is a proof of concept. They are giving guideline for you to implement digital securities, but then they don't force you to use ERC20. This is just a guideline. So by right, blockchain technology should be agnostic, means you can deploy it to different blockchain. using the same underlying concept. Yeah, but whether the effort is substantial or minimal, it depends on the technology that you have chosen and the new technology that you want to migrate to. Right, we have 2 more case studies. Let's finish it first. Then the third one is a private company B. So this company would like to launch a cross-border e-wallet, which can be used to perform micro-transaction. It must be fast, low transaction fee, and able to support high transaction volume. So which blockchain technology will you choose? Yeah, so this one is quite obvious that we will use Stellar. So Tron is nothing wrong, but then for Stellar is faster than Tron, so it's more suitable for micro transactions. Obviously, we don't use things like Bitcoin because it's micro transaction. Imagine you want to buy a Ramly burger and you pay in Bitcoin. First thing is the block time for Bitcoin is about 10 minutes. So means after 10 minutes, the burger seller can only receive the money. That doesn't make sense. Secondly, the transaction fee for Bitcoin is very high. This is what we call a gas fee, probably around 20 cents US dollar. So to buy a 4 ringgit burger, that you pay 80 cents as a transaction fee. So we don't use Bitcoin. Stellar comes with the advantages of the transaction time is fast, transaction fee is very low, and it supports very high transaction volume. Then the case study number 4. Company C would like to launch a social networking platform for the public. The functions are create, post, likes, comment. Users need to pay to unlock premium contents such as exclusive video. The platform must support millions of concurrent users. What blockchain technology would you recommend them to use and why? So let's go to the next question. So the answer is don't use blockchain. Yeah. So because the reason being is we need to support millions of concurrent users. And in these platforms, there is not much of the trust issue. So of course, this is a tricky question. We don't actually insert an option to use blockchains. So for those who didn't select anything, then you got the right answer. Okay. So none of the blockchain technology actually support millions of concurrent transactions at the moment. So at most could be up to 20,000 transactions per second. And there is no trust issue. These are standard social media. Unless you are talking about you want to create a decentralized social network which is privacy first. And things like that, yes, but then this is not part of the requirements. So that's why don't use blockchain for case study 4. Then before we move into the last session of today, any questions about the case study? Yeah, I know some of the case study could be arguable, debatable. There is no the right or wrong answer, but for me, I'm sharing our prefer and the better answer only. We'll move on to the last session of today, which is to study about our work to you. So as you know, work to you currently is developed using quantum blockchains. So why we use blockchain is we want to ensure even our developers cannot tamper the result. So that's why we use blockchain. Then the blockchain in work to you currently is actually quite straightforward. When user casts a vote, we have our centralized database on Azure SQL. At the same time, the votes will go to the mirroring DB, which is on Quorum. So that when there is discrepancy, then we have 2 databases to check against. This one is vulnerable to tampering. This one is not vulnerable to tampering. So this is our approach at the moment. But now we'll discuss how can we make this better. And this is a more detailed architecture diagram. So basically, when user casts a vote, we go to our app service. And then from here, it will go into a smart contract, Azure blockchain service. Appearance is something like either scanner. Basically, it's a blockchain explorer. Then the same set of data will go to Azure SQL. Appearance blockchain is either scan or quorum, so that from here we can know the block number, the transaction data, the timestamp, and so on. So this example of the dashboard is like the light version of the ether scan, but not so powerful. So in our centralized database, after we insert the block into the quantum blockchain, we will store the block number here for cross-reference. So alternative implementation is using Fabric and UPort. So UPort is an technology based on Ethereum. So let's say if you're using Fabric, we will use a function called membership service provider. So some of you who use this thing, MetaMask. So this MetaMask is actually a wallet that store your cryptocurrency. Whereas for Hyperledger Fabric, it is suitable for us to interface with some legacy system. For example, in enterprise system, we use Microsoft Active Directory. So you will log in with Active Directory, then the directory will speak to Hyperledger Fabric membership service provider. So if you map a user in Active Directory to a private key or so-called certificate in Hyperledger Fabric, this is what membership service provider is using. Then one of the idea is basically we use Hyperledger Fabric in order to complete the voting. So this is more decentralized. The idea is each of the company, they need to register as a membership service provider here. Then with that, we authenticate. So after they log in, then we retrieve to the right certificate and they will cast their votes. So all these words store only in Hyperledger Fabric environment. There is no centralized SQL database like what we are doing now. This is one way using Hyperledger Fabric. The other approach is using Ethereum. There is an application called UPort. UPort is being used to conduct elections in some of the country. And it's not a general election, it's just a small district or area elections. So if you are using UPort, then we can decentralize the identity. But the shareholder have to register with UPort. Then after that, our system will basically get the identity from the UPort applications in order for them to do the voting. So we are compare against like what we are doing now and against using Hyperledger and UPort. So our solution can work with all three, but just that the difference is whether ours one is fully decentralized, fully or partially decentralized, and whether how many transactions they want to achieve, and also go to the learning curve and set up and technologies. So there's no right or wrong, but we need to choose the best technologies according to what we need. Yeah, so that's the last slide that we have. So now we open for Q&A. So Vote2You is a product in production already. Then currently more than 50 public listed companies are using our product to host their AGM online. And it's actually featured in the Edge as well. So then back to the questions here. What programming language that we are using? So we use a C# code, and then the other part will be Solidity for the Quorum blockchains. Yeah, so if you're talking about a case study, then we have done more than 50 AGM, so these are real ones. And the other one is MMU blockchains for the e-voting. But this is not using Vote2You.
Let's say we have a working systems and we have planned to integrate with the blockchain. So how long and what is the requirements to do so?
Software projects, the duration always depends on the complexity, number of data that we need to interact with, and whether the level of interactions that we want to change or not. So back to our sample case study in Vote2You. So in Vote2You, this is a more mainstream way of using blockchain as a mirroring. So if you are using mirroring approach, then probably between 1 to 3 months, then you can have the project completed, because you still have your same set of data here. Then using some queue services and so on, then we insert data into our blockchain service. But if let's say you want to decentralize everything, means even user login, you also want to change and so on, like using the Fabric. So things like that, then you need to set out membership service provider and also to sell all the nodes and so on. So this could take 6 months to 1 year. So it really depends on to what extent of decentralized level do you need.
Register to MSP, how long does it take? Just now you said.
Okay, so register at MSP means MSP is a software, means membership service provider. Actually, it's a software lah. So this is a component inside Hyperledger Fabric. But in general, to implement the whole thing, so go back to the first one. So let's say your intention is only to mirror the data. So that one will take between 1 to 3 months lah. Depends on the amount of data that you want to store in blockchain. So this one doesn't affect the user login. Then the second one, if let's say you want to use Fabric, so we also have to set up membership service provider so that when user log in, then we will actually retrieve insert data into blockchains. So this one will typically take 6 months to 1 year, depends on the scope as well.
When the shareholder login or register, does it do the authentication to the Hyperledger instead of the Azure database?
Okay, when shareholder log in, they will actually still go to our, okay, so they will go to our conventional login system. Because shareholder, okay, so go back to the other one. Okay, there are 2 ways of login in the blockchain environment. So first way is using membership service provider. So this one from shareholder perspective, they still use a conventional way, such as phone number, email, and so on. So after they log in, our system will generate a JWT token, and this JWT token will retrieve the certificate from the membership service provider. So meaning to say the shareholder doesn't have the private key. That's why we call this partially decentralized. Then there is another approach, which is so-called a fully decentralized, like this one. This MetaMask. MetaMask, let's say I go to a decentralized applications, Crypto Kitty. I want to buy a crypto cat online. Then this one, if you log in, there is no such thing called login or register, because everything is using your private key locally. That's all. So you don't see I log in, right? There's no such thing called login. I basically just authenticate my private key in my wallet to use the applications. Then I can buy the cat now. Of course, I don't want to buy this cat. This cat is 150,000 US dollar. Yeah, this is so-called a fully decentralized version of the blockchain applications, meaning to say your user, they don't log in by email, phone number, and so on. They basically have the responsibility to store the private key in their device. Whereas, let's say the private key is lost for whatever reason, no one can help them to recover the key. So that's why at this juncture, we still think either using the first or second approach. The first one is just basically the data mirroring. The second approach is basically using the membership service provider, but users still use their login or by phone number or email. They don't store the private key themselves.
The system does not, the vote to you does not keep the user ID and so on. You just authenticate.
Okay. If you really want to go into detail, there are many things they are doing inside. So, but from technical perspective, the user basically they just log in. But then if you ask me about from the business perspective, then I share a bit on what we are doing here. So when user first register an account, we will do a eKYC because you have to understand whether they basically need to upload an IC. So from the IC, we know whether they are the legit IC owner or not. So after that, we will check with Bursa. Basically, there is a file called records of depositors. Then we know whether they are shareholders for this particular company or not. That basically how it works for work to you. But those are centralized implementations. The one that I shared earlier is more on the decentralized part. Yeah, I think we can open for one more questions. And we open for one of the top audience in the sharing. And you get 100 ringgit worth of Bitcoin. Any further
Hi,
question?
I've got one question.
Yeah.
So after going through this sharing session and also after read briefly about blockchain, for me, technical person still can barely understand how Bitcoin works. So how do you actually position your solution, the work to you, or to promote this app as a secure kind of app to the business people? Do you really explain to them that you are using blockchain, and does the user or do them actually understand that your application is secured because of the blockchain, or you need to explain the whole blockchain technology to them in order to win their trust?
Yeah, I think this is very good questions. You're right. Blockchain is a very difficult technology, even though for technical persons like developers and so on. So for business, they are even more blurred. They don't really know what's blockchains. So to make things simple, actually, we get people to audit our platforms. So yeah, so basically we get crowd Howard to audit our platforms, so they test everything. So from the outcome, then they endorse our platforms. This is what from business perspective they look at. So because they are not technical, so they have to trust an independent auditor to audit our platforms, go through our full application control, make sure there is no control lapses. That's why that's how we convince the business lah. Yeah, so I think now let's open the floor to one of the audience here to summarize what you have learned today, and then how do you think today's sharing can help your job or helps your project in the future?
It's an emerging technology that can be used to improve our processes and to convince our customers. But it actually depends on your situation. How do you want to use this blockchain technology? And we as a technology provider, we can say that we can advise to our customer why we need to use blockchain in our environment. From this session, actually, I do understand the processes in the blockchain, because from previously I've read from a few articles, and it's a very good approach and knowledge. So maybe after this, what I need to do is to make comparison between the Ethereum and existing blockchain provider, which one the best and can fit to our organization.
Yeah, all right. Thank you very much. I think that pretty much sum up today's sharing sessions. That's very true. Yeah, so I think I will pass back to Felicia. So is there anything else that you want us to share further, or? Yeah, I will also put my contact in the chat room if you guys want to reach me.
Sorry, Ron. I have this scenario where we can apply this blockchain concept in customs. Say customs is planning to apply this technology, blockchain technology, in their business. Customs department. So where do you think it fits? I mean, to apply this technology?
Yeah, I think custom, because due to custom is very important to control the borders and so on. So definitely there are a lot of areas that we can potentially use blockchains, since it is related to storing sensitive data and so on. So I would say today's system more or less is very fragile in nature, that even though we have very good like privilege access control, then we have the audit trail, store all the IP and so on. But due to the nature of still being centralized, it is very easy for us to tamper data and then update the audit trail, so that even after I tamper data, still no one know I have tampered data. So that's why for custom, I think it is very important for you to have a POC to try to store some sensitive data, at least in the mirroring approach. Then from there, you actually know, after a while, you do some reconciliations to compare the one in the blockchain with a centralized server. Then you can actually find out some surprise. Maybe some data, I'm not sure, but then could be some data that could be less of integrity that you will know after a while. So our recommendation is try to POC with one or two small table in a blockchain environment, then you will see the impact moving forwards. So start small. To me, I think the easiest way is to use the, and let me share the resources here. So there is a website called remix.ethereum.org that I put in the chat room. So this one is actually very easy to use. You just use your browser. You can start to develop smart contract. Then after that, it comes with a test environment as well. So it's very easy to learn. But of course, Ethereum might not be able to do everything, but it is good enough for you to start blockchain development.
Yep. Thank you. Thank you, AK.